Hey guys, welcome to another video from Abear Engineering. If you're a student or just someone in general wanting to learn math and engineering subjects, then subscribe. What are you doing? You need to subscribe. You're missing out on highly valuable content. And after watching this video, if you enjoyed it and you don't drop a like, that's messed up, man. If you didn't enjoy it, I understand. But if you enjoyed it and you don't drop a like, I mean, that's crazy. That's craziness. Okay, so this problem says that a patient receives a 150 milligram injection of a drug every 4 hours. The graph shows the amount F of T of the drug in the bloodstream after T hours. Find the limit as T approaches 12 from the left of F of T and the limit as T approaches 12 from the right of F of T, and explain the significance of these one-sided limits. So all this problem is trying to do is to get you to think of the concept of a limit in real life. Okay, so at time 0, they inject 150 milligrams of the drug. 4 hours later, they inject another 150 milligrams. 4 hours later, another injection. 4 hours later, and this is the point that we're looking at. This at time t is equal to 12. So the limit as t approaches 12 from the left of the function f of t is 150. What does that mean? So coming from the left here, the patient has already received 1, 2, 3 injections. The third injection is breaking down in the bloodstream more and more. So this limit is like when the nurse has come in to do the 4th injection. Right before doing the 4th injection, the amount of the drug in the bloodstream, this function is saying, is 150 milligrams. Right before doing that 4th injection, okay? And then the limit as t approaches 12 from the right, so here, is equal to 300. And what does that mean? So that's right after the drug has been injected. Okay, but you can think of this open circle. So right after the drug has been injected, the 5th injection, effectively you can think about the patient having 300 milligrams of the drug in their bloodstream. But just if you can think about this open circle though, it's kind of like, to me, it's saying that, well, almost like instantaneously while they're injecting the drug, it's instantaneously being broken down the moment a drug starts going in. So it's never really equal to 300 milligrams because it's like automatically being, right when they inject it, it's 299.99 milligrams. But the limit is telling you that you can effectively think of it as 300 upon the 5th injection. But here, coming from the left, you can think of it like at the 12th hour, right before they do the 5th injection, or the 1, 2, 3, the 4th injection. This is the 4th injection. Right before they do the 4th injection, it's effectively 150 milligrams in the bloodstream, but it also, once it gets to t is equal to 12 hours, that is exactly what they have. Or not exactly, but according to function. So you see how you can think of this, how you can interpret, look at this like this is a good problem to see like a jump discontinuity in real life. Like, where would a jump discontinuity come from? Something just like this. And also you can think about limits in real life. I mean, obviously, if you were like a nurse or a doctor or whatever, you wouldn't have this graph and then talk about what is the limit as t approaches 12 from the right. That's a little overcomplicating it, but it still gets you to think in terms of limits in reality, because you can apply limits in other situations that maybe it's not that silly to talk about a limit in some other type of analysis.